All right, hi folks. Obviously I am not here today. I still have a lesson to get through, and normally you've seen these before. I will like get my iPad to screen share to the Zoom, and then you sort of see me do all that business just on my iPad. I couldn't get it to work, so hopefully the setup is going to work for us. All right, we're in the multiple angles notes, so go ahead and just make sure you're set up for that. You still have a warm up, so I'm going to say pause the video, try the warm up, and then come back. Give yourself like 4 to 5 minutes. Just try it out, and then come back when you're done. All right, so go ahead and pause. All right, and then hopefully now you're unpausing, and we can go ahead and move forward with these problems. If you did do the warm up, if you didn't do it, pause the video, do it. Otherwise, if you're ready to see some answers, let's try it out. So we're solving for alpha between, oh God, when it rains, it pours. Can't get anything to work. Give me a sec, and I'm going to see if my Apple Pencil will reconnect. Fingers crossed. Hey, there we go. All right, so we're solving for alpha between 0 and 2 pi. And so I want to isolate that trig function first. I'm going to add the 1 from the left to the right. So we have tangent of alpha is equal to 1. That's going to occur in 2 different quadrants, quadrant 1 and quadrant 3. So with a reference angle of, and I'm looking at radians, as it says 0 to 2 pi, not 0 degrees to 360 degrees. And when my answer is in radians, we're going to say pi over 4. And then in quadrant 3, 5 pi over 4. All right, so that'd be your answer for the green problem. For the yellow, solve for beta between negative infinity and infinity. We're solving for all reals. So I'm going to do a similar thing here. We're going to isolate the trig function. So we're going to add the 2 from the left to the right. So secant of beta is equal to 2. And then take the reciprocal of both sides. So the reciprocal of secant is cosine. The reciprocal of 2 is 1/2. And so now we're looking, okay, where is cosine equal to 1/2? Well, that would be in quadrants 1 and 4. The reference angle of pi over 3. So your principal angle here would be pi over 3. And this would be 5 pi over 3. But we're solving overall reals, right? So I can't get both of these terminal arrays to line up with the same sort of period. So we're just going to treat these as separate. So let's go purple here. Let's go pink there. But beta is equal to pi over 3 plus 2 pi k, where k is an integer. And then also 5 pi over 3 plus 2 pi k, where k is an integer. All right, so that would be the yellow. And then we get to red. So solve for gamma between 0 and 2 pi, where 2 sine of 2 gamma minus 1 is equal to 0. Well, we can do some of the same steps as what we did above. So I can add the 1. I can divide by 2 and say sine is equal to 1/2. Right? We know where sine is equal to 1/2. Right? So that'd be in quadrant 1, in quadrant 2, the reference angle of pi over 6. But our angle here isn't gamma. Our angle for this particular trig function is 2 gamma. So I would say that 2 gamma is equal to pi over 6, comma 5 pi over 6. Right? And so then what do you think we're going to do to get to gamma? Hopefully not too big of a leap. Just say that we're going to divide by 2. Right? So pi over 12, comma 5 pi over 12. Here's the thing. That is half of the solution set. We are still missing solutions, right? The reason why, and to do this, I'm going to get close. Screen share. Where is it? This one. Okay, so now I have Desmos open. Hopefully you're seeing that. I'm just going to sort of type in a function here. So let's start with y equals 1/2. Right? And then I'm going to set up a piecewise. So where x is between 0 and 2 pi, I want sine of 2x. So in this case, x is sort of just standing in for gamma, right? So I set up the 0 to 2 pi because our solutions are supposed to be between 0 and 2 pi. This is the sort of the left hand, if you can still see my image off to the side, the left hand of our equation, sine of 2 gamma. So that's going to correspond to sine of 2x. And then we just said that we want that to equal 1/2. So I just set up a horizontal line to equal 1/2. Right. So you can see over here that I have 1, 2, 3, 4 intersection points between the blue curve and the red line. So there's supposed to be 4 solutions that I'm trying to find. Right. Now, pi over 12 would be my first solution here. You can see how the x value is pi over 12. 5 pi over 12 would be my second solution. Again, the x value is 5 pi over 12. Right. And so the question is, well, what's going to happen with these other 2 solutions? Right. It may be helpful to think about what actually happened with this 2 in front of this 2x, right? If I took out the 2, you would see, okay, well, that's just a pretty normal sine curve, right? Just one cycle of a sine wave, right? And here's where we had that pi over 6 and that 5 pi over 6, right? And so when we put in the 2, what's happening with the sine wave? The sine wave is contracting, is horizontally shrinking, right? So the period is getting smaller, but over the same window of 2 pi, we're then picking up more periods, right? So if we were going to take the period and horizontally shrink by 2, I should expect twice as many solutions to show up, because originally I would have 2, but then with the second period, I would have 2 plus 2 is 4. Right? And so that's really kind of what we're going to do. If I can hop back over here, in terms of finding more solutions, right? I'm still missing 2 solutions in both of these steps, right? And just to give you more representations of how that's happening, if we're dividing by 2 to get from this step to that step, if we're dividing by 2, but I want to end here with gamma in the interval of 0 to 2 pi, then really I should be looking at 2 gamma in the interval of 0, comma 4 pi, right? If I was to divide 4 pi by 2, I would get 2 pi. If I was to divide 0 by 2, I would get 0, right? So by setting up 2 gamma to be between 0 and 4 pi, then when we divide everything by 2, I've actually already basically checked everything between 0 and 2 pi. I'll just divide the numbers by 2. Okay, so this is really like the big push of these types of problems. It's not getting the trig function by itself. It's not actually the act of dividing by 2, because that's pretty light. It's knowing what interval you want to look over so that you know that you're hitting 0 to 2 pi. So if we are looking at 2 gamma, I just want to double this 2 pi so that when I divide off this 2, I'll still get back to the 2 pi at the end that I wanted. Okay, so let's take a look now at the interval from 0 to 4 pi. So that'd be 2 rotations around. This first intersection on that first part of the rotation, that was the pi over 6. If I don't make it for a half rotation around, that would be 5 pi over 6. But if I go around for a full rotation, and then another pi over 6, that would be 12 plus 1 is 13 pi over 6. Right? Then if I went around for 12, and then for another half rotation up to 18 pi over 6, then back by 1 pi over 6, this would be 17 pi over 6. So then I'll just divide by 2 and get 13 pi over 12 and 17 pi over 12. So this would be my final answer. Those are the 4 angles that I'm looking for. Pi over 12, 5 pi over 12, 13 pi over 12, 17 pi over 12. And let's just confirm that real quick. If I hop back over into Desmos. So again, I had between 0 and 2 pi, sine of 2x, and I was trying to see where that function equaled 1/2. We had pi over 12, 5 pi over 12, 13 pi over 12. So that matches up with our answer that we wrote there. And then 17 pi over 12 right here. So that looks pretty good. Even though I'm not in the room, I feel like I can hear people saying like, what? Huh? I'm not quite like, what's going on there? Some people, I'm sure, probably get it, but let's just do another. All right. So we've got 2 cosine of 3 alpha plus 1 is equal to 0. No restrictions necessary here because we're just dealing with cosine. So I'm actually going to start with what I think the harder part is first, now that we've sort of seen it. If we're going to be tackling a 3 alpha, but I still want a single alpha to end up at between 0 and 2 pi, then what interval should I look between for 3 alpha, right? Well, 3 alpha should be between 0 times 3 would be 0, and 2 pi times 3 would be 6 pi, right? So I'm going to solve this equation for 3 alpha. And before I divide off the 3, I'm going to look between this interval to get all the values for 3 alpha that I might find between 0 and 6 pi. Then we'll divide off the 3 and everything will just collapse down where we wanted them to. So subtract the 1, divide by 2, cosine of 3 alpha is equal to -1/2, and that's going to occur here and here. Right, but if I'm looking between 0 and 6 pi, that means that we have to go around for 3 rotations. Right, so 1, 2, 3. Let me go highlighter here. And so then if I look at where sort of the path of that rotation hit those terminal rays, I can see that I'm looking for 1, 2, 3, 4, 5, 6 solutions for 3 alpha. Right, so 3 alpha is going to equal this terminal ray on the first part of the rotation would have been 2 pi over 3. And then down here, this would have been 4 pi over 3 within the first rotation. Right, and now that I know they need 6, I actually can make this a little slightly easier. Oh, hello, for myself, by just knowing that each of these angles on this terminal ray have to be coterminal. So if 2 pi over 3 was my first angle here, then I can just add 2 pi to get the next angle in my sequence. Or maybe more appropriate here would be adding 2 pi in the form of 6 pi over 3, right? So I already have my common denominator baked in, right? So this is just adding 2 pi for the coterminals. Right, and so then 2 pi over 3 plus 6 pi over 3 would be 8 pi over 3. I'm actually going to do that again just to get the last coterminal. But that would be 8 plus 6 is 14. And then pi over 3. And then I'll do the same thing, right? So this angle right here is 4 pi over 3. And I'm going to add a 2 pi to get to this angle. 4 plus 6 would have been 10. So 10 pi over 3. And then we'll do that again. So 16 pi over 3. Right? So 3 alpha is equal to any of these 6 values, but we're solving for alpha. So the last thing I just have to do is just divide off the 3. So alpha, and then I'll take all those angles and divide by 3. So everything basically that was over 3 is now over 9. So 2 pi over 9, 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, 16 pi over 9. Right, and that would be the final answer. I'm just gonna do one more, and we'll just finish off page 2. Right, so solve for all real solutions of beta for this interval here. And now here's the thing, right? I don't need to be messing around with trying to figure out how many solutions I want or, what a special interval is, just because I'm solving over all reals, right? So there's not really any sort of shrinking of intervals because I can't really shrink down the infinities. Those are just sort of what they are. So what we're going to do is just solve this equation straight up, get to the sequence that we would have used for all reals, and then just adjust when we divide off the 2. Right? So hopefully pretty straightforward in the beginning. I'm going to subtract the 3, right? So we end up there. I'm going to divide off the 9, and you might want to do 1/3 as your gut instinct. I'm actually not going to because I can see the square right here, and I know I'm about to square root some stuff. So I'd rather just leave a 9 down in the denominator and square root 9, you know, probably would be easier. Tangent of 2 beta. I use the square root method. I'm going to include the plus or minus. Oh, I'm sorry. Wait, is this even possible? Yo. Oh, that's not possible. Damn, that sucks. There's a typo. I'm going to fix it by the time you see this video, which is why some of you are like, I think we have different problems. It should be positive. I'm sorry, this should be negative right here. So this is positive. That's positive 1/3. And now we can square root 3/9. Okay, I'm going to change that. Anyway, so plus or minus because you use the square root method, and then I left the 9 and didn't reduce, so that when I square rooted, I just had a root 3, and then the square root of 9. Ooh, come on, bro. Is nice and easy and just 3. All right, so where is tangent equal to plus or minus root 3/3? That's anywhere that we have a reference angle of pi/6. So in the first rotation, pi/6, 5 pi/6, 7 pi/6, 11 pi/6. And so we could write 4 different sequences for the 4 different terminal rays. If you pick up that we could pair off the terminal rays and just use a period of pi instead of 2 pi, something to think about. I'm going to go with that method just for the sake of writing, and then I'll just write up what I think the other answer could be if you went for 4 sequences. But my first sequence would be pi/6 plus pi k, right? Because I have 2 angles here that are pi apart. So pi there, another pi, another pi, another pi. And that's where k is any integer. And then in the green, I could do 5 pi/6 plus pi k, right? Same common difference, just a new initial term, right? So if I was to do that, then I would just divide by 2 on all components of these sequences, right? So now I'm going to end up with pi/12 plus pi/2k, where k is any integer, and 5 pi/12 plus pi/2k, where k is any integer. Right, so just dividing both the initial term, so pi/6 becomes pi/12, and the common difference, so pi becomes pi/2. Right, so this would be the answer that I would go with. The alternative answer that I think you might maybe have written is pi/12 plus pi k, 5 pi/12 plus pi k, 7 pi/12 plus pi k, or 11 pi/12 plus pi k. Right, and that would be if you wrote a sequence for each 1, 2, 3 of the 4 terminal rays, and then divided everything by 2, right? So this would be just for this terminal ray, pi/6 plus 2 pi k, but then I divide the pi/6 by 2, get pi/12, and the 2 pi k divided by 2, pi k, right? And the same for all the other 3. So hopefully we're feeling good about just the algebraic mechanics of getting from step to step. And I think the push, rewatch the video if needed, is going to be just when do I need to look for these intervals? When do I need to look beyond 2 pi? How far am I supposed to look? And then what do I do with these reals, which I think is the thing that we're still working on. So yeah, that's the notes. Hopefully this went kind of well. We will touch up on it as we move through this unit. So sorry I couldn't be there today, but see ya next time. Okay, bye.